So in this video looking at construction, we'll be focusing on how to construct triangles. Now there are three types of triangle you may get asked to accurately construct based on the information given to you. So the first thing you need to do is when you're given a question of constructing a triangle, you need to establish which of these triangles it's going to be. Now one of the types of triangles it's going to be an SAS, which basically stands for side angle side. The second type is an ASA, which represents an angle side angle, and the third type is an SSS, which represents a side side side. So just as an example of stating the type of triangle we need to construct, so let's have a look at these three. So in the first question here, I've got an S, which is a side. 4 centimeters represents a side, 80 degrees represents an angle, and 8 centimeters represents a side. So that's going to equal an SAS triangle. In the second question, here I've got an angle, I've got a side, and I've got another angle. So that's going to be a angle side angle triangle. For the third one, I've got a side, 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 so that's just going to be an SSS triangle. For the fourth type, or here I've got an angle, and there I've got an angle, and there is a side. So I'm not going to call this an AAS triangle, I'm going to call it an ASA triangle. And again, it doesn't, all this the only point of it all doing this is just establish which method you need to do, because obviously the methods for each of these three triangles is going to be slightly different. So for question 5, that's an angle, I've got a side, and I've got a side. So no, this is not going to be an AS triangle, it's going to be an SAS triangle. And then finally, we've got 45 millimeters, which is a side, 7.8 centimeters, which is also a side, and I've got 160 degrees, which is an angle, so that's going to be an SAS triangle. Now once you've established what type of triangle it is, the next thing we then move on to is the method that we need to use. Now like I said, there is a copy of each of these methods, but I will go through them now with you, so feel free to print the instructions off and then you can learn from it. So the first thing you want to do is draw the longest side. So once you've established that the triangle you've got to construct is an ASA, so for example, if I had 7 centimeters, an angle of 60 degrees and 6 centimeters, then it says to draw the longest line. So here I would draw the 7 centimeter line. The next thing I would do is find where 60 degrees is on my protractor from one end. So I'd put the center of the protractor at one end of the line, I'd go up to 60, and I'd put a little dash of where 60 degrees is. And then the third step is measure and mark. The fourth step is draw a projection line. So from that mark, which you could say is there, I'm going to draw a horizontal a line through those 2 points. I was going to say horizontal, but we've already drawn that. So for example, what you do is draw a line through that point, and get the mouse because I messed that up. And so what you should have is something that looks like, oh, it's a little bit more difficult, there we go, that goes through that mark. Obviously a little bit more accurate because of the computer software. The next thing we then need to do is measure the second length, which in this case was 6 centimeters. So again, what I'll do is I'd measure where 6 centimeters was and put a little dash. And then with that dash, what I'll then do is connect that up to the opposite end of the baseline to then create my triangle. Now, if you had an angle side angle, so for example, if I had 60 degrees, 40 degrees, and let's say 6 centimeters, then the first thing I'll do is draw the side, which is 6 centimeters. From one end, again, making sure you've got center protractor on one end, I'd measure one of the angles, so let's just go for 60 degrees. So if I marked that was 60, put a little dash there, which I've done there, and then draw a projection line through that little dash. You repeat the process on the other end, measuring the opposite angle. So in this case, I would measure 40 degrees. So over where 40 was, I'd put a little dash next to it and then draw a projection line through that point. So this angle here would be 60, this would be 40, and the length would be 6 centimeters. And there I've got my constructed triangle. Now the key thing to remember here is do not rub out any projection lines, which is really, really important. Okay, although it doesn't look like a triangle, feel free to go over it with a pen or to emphasize the triangle, but never rub out your projection lines, because that's like you're working out an evidence that you've used the correct method to plot this rather than simply guessing. And the next type of triangle is an SSS triangle. Now this is where you're going to need a compass rather than a protractor, because obviously there's no angles involved. So for this, what you need to do is draw the longest line, which obviously does help. Now this is not essential, but I strongly recommend that you do. Set your compass to one of the lengths, and then you draw an arc from one end. So you put your pin at one of the end, and what you do is under the one of the measurements, you draw an arc. So for example, if I was going to draw a triangle with 6 centimeters, 5 centimeters, and 4 centimeters, then this would be my 4 centimeter line. I'd set my compass to, let's say, 5 centimeters. I would draw an arc so that the radius of this distance here would be 5 centimeters. I'm then going to set my compass and rearrange to the other length, which in this case would be 4 centimeters. And then I repeat the process from the other end. So I put my pin here, and this length here would be 4 centimeters. And what you should end up with is 2 arcs. I should have one arc for one length and a second arc for the other. And what you should find is that the 2 points meet at an intersection point, which is this point here. So that there is my intersection point. Now, if you don't have an intersection point when you're drawing an SSS triangle, you've definitely gone wrong somewhere. You should always have a intersection point. If not, it might be an impossible triangle for you to then draw. Now, once you've got your intersection point, what you've got to do is just join the opposite ends of the baseline to that particular point to form a triangle. And again, do not rub out your projection lines, because again, that acts as you're working out. So please do not do so. Doesn't matter how messy it looks. If it's right, don't rub it out. Now, as mentioned, a very popular question that comes up is recognizing triangles that you physically cannot draw. Now, there are some triangles that it's impossible to draw, and it's one of these 3 things. So the first one is that you can't draw a triangle with 2 obtuse angles. Now, again, obtuse means you've got an angle that is more than 90. Now, in a triangle, you've got 3 angles, and if 2 of them are more than 90, then your answer is definitely going to add up to more than 180, because you can't have negative angles. The second one is a triangle where 2 angles alone added together is over 180. So for example, if I had an angle that was 150 and let's say 40 degrees, then as both of them, and again I could pick another angle, but as this angle here is obtuse, this one is acute, the fact is that when I add them together, they add up to make 190 degrees, but I need to add another third number, which is going to be the case. So again, any 2 angles added together must not go over 180 degrees. And the final one is a triangle where if you add 2 sides together, the answer is less or the same as the length of the remaining side. So for example, in terms of this, and one of the reasons why is the 2 arcs won't cross. And again, I'll do an example when I go through how to construct an SS triangle of when that would happen. Now, what I mean by spotting it is if I have 7 centimeters, let's say 2 centimeters and 3 centimeters, well, if I pick any 2 sides, the answer has got to be bigger than the side I've not added together. So here, if I did 7 plus 2, which is 9, is that bigger than 3? That's fine. If I picked 7 plus 3, is that bigger than 2? Yes, it is, because that's going to be 10. But if I did 2 plus 3, that's not bigger than the remaining side, so therefore that would be an impossible triangle. Again, likewise, if I had 6 centimeters, 3 centimeters, and 3 centimeters, that if I added these 2 numbers together, it would be bigger than the third angle. If I added, let me rub this out, if I added these 2 angles, this one and this one, it would add up to a total that's more than this angle that I've not used. However, if I used this angle, this side and this side, that equals 6, and that's not bigger than the remaining side. So therefore, this would also be an impossible triangle. So, like I said, the best way of learning the methods of constructing these triangles is to go through some examples. So what I'm going to do is I'm going to have a go at working through these 10 questions. Now, if you're wanting to have a go based on the instructions that you've got in front of you or may have downloaded, then please do so. But what I'll do is I'll now go through how to construct or how to answer each of these questions. So drawing the first triangle, which we've got is 5 centimeters 7 centimeters and an angle of 45 degrees. Sometimes what's always a good practice is to do a little sketch of what your triangle is going to look like. So first things first, your longest side will always be your base. I'm going to have one side which is 5, one side which is 7, and this angle here which is going to be 45 degrees. So as we said, the first thing you want to do is measure the longest side, which in this case is 7 centimeters. Now you do need to take extra care when it comes to the measurements. It needs to be exact, not 7.1, not 7.3, not 6.8, not 6.9, needs to be 7 centimeters. Now what's also very good practice is if you label as you go along. Now the next thing I've then got to do is then get my protractor and measure the angle. Now again, with your protractor you need to find the center of your protractor, which is usually where the 90 and the 0 meet, and obviously where the 0 is. So I'm going to put 0 on the line, and I'm going to put the center of the protractor on this end here. Now if you do a little dot, then make sure it is a little dot, because what you don't want to do is extend that 7 centimeter line. So I'm going to try and get that exactly how it is, you can see there. Now the 0 is on the inside numbers, so they're the numbers that I need to use. So wherever 0 is, so if 0 is on the outside, you use the outside numbers, 0 is on the inside, use the inside numbers. And what I need to do is then find 45 degrees, which is there, and just put a little dash or a little mark of where 45 degrees is. So the next thing I then need to do is to then draw a line through the edge of the end of the line through that marking of 45 degrees. And this here, I'm going to label this 45 degrees, and I'm just going to label this as my projection line, because on the notes, if you're not too sure what the projection line is, then that is basically what it is. Now the next thing I've then got to do, so I've already done my 7 centimeters, I've done my 45 degree angle. The next thing I've got to do is measure the 5 centimeters. So again, I get my ruler out and I measure 5 centimeters along that projection line. And once I've got it all matched up, so the starting of 0 centimeters on the end, and I'll find 5 centimeters, I'm just going to put a little dash on the line. And the next thing I've then got to do is join that mark to the opposite end of my baseline, and I've got my triangle. Now one thing you don't want to do is never rub out your projection lines. So never rub out this line, because what you want to do is you want to show evidence that you have correctly drawn the triangle without simply guessing with a ruler what it should be. So it's really important that you do. Now don't worry if it appears that you've got lines sticking out and you can't see a triangle. There definitely is a triangle, and it does cover. Now if you were to draw, let's say, this extension line a little bit further, let's go like this, then that also should get you full marks, because like I said, the rest of them are just a projection lines. Now if you really wanted to be a bit of a perfectionist, you could go over each of the lines, and let me just label this 5 centimeters. And a typical question might ask you to either measure what this remaining side was, so let's just get a ruler, we can measure that, and that works out to be roughly around about 5 centimeters, or about 4.9 I would say. So again, you can go on from there to see what that should be. Now, so it is really important that you don't rub out those projection lines, and obviously you do label each of the sides, and again, you might get asked in another part of the question to measure what these other 2 angles are going to be. So moving on to our second example, which the second example was 7.2. So this time dealing with a bit of decimals, so just need to be a little bit careful when we're using our ruler. 32 degrees, which is more of an awkward angle, and we've got 6.4 centimeters. So again, with this, what I'm going to do is I'm going to measure the longest side, which in this case is 7.2. So find 7.2 on my ruler, and then mark it as such. And again, it's really good practice for you to write and label your lines as you're going along. So the next thing I then need to do is do the 32 degrees. Now, which side does the 32 degrees need to go on? It doesn't really matter. So this time, just to mix it up, I'm going to go for the opposite side. So I'm going to put 0 on the line and the center of the protractor at the end of the line, as you can see there. Now 0 is on the outside numbers, so I'm going to use the outside numbers to measure 32 degrees, and 32 degrees is about there. Then with a straight edge, I'm then going to draw my projection line. So I'm going to leave the ruler and use the protractor, the edge of the protractor, to draw my projection line. and this angle here is 32 degrees. So the last thing I've now got to do, or the second to last thing I should say, is measure the 6.4 centimeter line. So again, I'm going to measure 6.4 along that projection line. I'm going to put a little dash there, and then from that dash I'm going to connect that with the opposite end of my baseline, and lo and behold, just label the diagram, and there you go. Now you might find in some exams it might do a little sketch just like we did here, where it might ask you to draw it accurately. And so what you kind of need to do is just make sure that the angle is on the same side, the side is on the same, and you go for there. But definitely when you're in class, I would definitely opt for drawing, starting with the longest baseline and then moving on to the other measurements. Now in terms of the third question that we had, so we had 140 and we had 6.1 centimeters and 5.3 centimeters. So looking at these, we know it's going to be an SAS triangle, and you can see that the order in which the information is given to me doesn't necessarily need to be in that particular order, but I do know that there is an angle, that there is an S, and that is an S, and it is an SAS triangle, not an AS triangle. But there you go. So again, starting off with this question, I'm going to start off by drawing the longest side, which is 6.1 centimeters. Now one thing I do notice about this is I've got an obtuse angle, so that means that the triangle is going to have an obtuse angle, so it's going to look something that looks like this, where this is 140, this is going to be 6.1, and this is going to be 5.3. Now a common question that I always get asked is, how much space do I need to leave, particularly when you're in an exercise book, how much space do I need to move up? Now if you think about the longest side being 6.1 centimeters, then I would roughly say leave about 6 centimeters in height of how much maximum space you're going to need. So you won't need more than what the longest side is going to be in terms of height. So again, I'm going to mark my length of 6.1 centimeters and just give that a quick label. And then the next thing I've then got to do is measure the angle, which in this case is 140. Now again, I'm going to go for 140 on this side. So again, 0 is on my baseline. I'm just going to be using the inside numbers to find 140, which is there. And then what I'm then going to do is use my projection line like so. So it's just a little bit more awkward when it comes to drawing obtuse angles, but the same thing kind of applies. So then the last thing I've then got to do is to measure the 5.3 centimeter line. So again, with my ruler, 5.3 along the line, put a little dash, and then connect the points up. Now again, being a maths teacher, you should always be doing your diagrams in pencil, but I'm just doing mine in pen just to make it easier for you to see on the screen, but I should be using a pencil, and that's 5.3 centimeters. Now when it comes to ASA triangles, so in one of the examples here we've got 50 degrees, we've got 5 centimeters, and we've got 40 degrees. And how do we go about doing this? So again, the format is exactly the same. You always draw the longest side. So again, leaving about 5 centimeters of space height, and we draw a 5 centimeter line. Like so. And again, I'm just going to start by labeling that. So the next thing I then need to do is pick one of the angles. Now I'm going to go for the 50 degree angle first, and it doesn't really matter which one you're going to go for, but again, 0 goes on the line, the center of the protractor goes on the end of one of the lines, and 0 I'm using is on the inside numbers, so I'm going to use the inside numbers to find 50. So again, 50 is there, so put a little dash, and then with that dash from the end of that line, I'm then going to draw a projection line, and that angle there is 50 degrees. Now for the next step, I then need to do the exact same but on the opposite end with the other remaining angles. So again, I'm going to put 0 on the line, and the middle of the protractor, or the center of the protractor I should say, at the end of the other line, or the baseline I should say, and this time I'm going to find 40 degrees. Now 0 is on the outside, so I'm using the outside numbers, and so 40 is going to be there. Then all I then need to do is join those points up, and then write it as 40 degrees. Now again, key principle here is do not rub out these lines. And also when you are marking this, try not to be too much of a perfectionist of making it exact. That is absolutely fine. And again, I'd much prefer to get full marks and lose a bit of an OCD in terms of making it look exactly like a triangle, because obviously that's what it is. Marks mean prizes. So our next triangle that we're then going to draw is going to be 35 degrees. We've got an obtuse angle in there, and we've got a length of 6.5 centimeters. Now again, what we need to try and do is do a little sketch of what this is going to look like. So here I've got my 6.5, I've got an obtuse angle, which is going to be here, so that's going to be 110, and this angle here is going to be my 35 degree triangle. So I'm going to need a bit of space going in this direction. So again, starting off by drawing the longest side. So I've got 6.5 centimeter line to draw, like so. And again, I'm going to label it. And then I've got to measure my 35 degree angle. So again, center of the protractor, 0 on the line. So 0 is on the inside. So I'm going to use the inside numbers to find where 35 is, which is just there. And then from that, I'm then going to draw my projection line, like so. Now the next thing I then need to do is then measure the other angle. So I'm going to put the protractor on the opposite end, center the protractor on the end. 0 is on the outside number, so I'm going to use the outside numbers to find 110. Now with this, you can see that I'm just going to ruin that sketch. You can see there that my lines don't quite meet. So what I'm going to need to do is just simply extend those lines so that it does, and just about avoids missing my diagram. So this angle here is 35 degrees. This angle here is 110. And like I said, if your projection lines don't meet, just need to make sure you just go that a little bit further. And again, in terms of accuracy, yeah, maybe I should have just go over that again, just to make it up. And again, really should have used a pencil. And there we go. And then with the last question on this particular section, we've got 7.3 centimeters and 60 degree and 60 degree. Now one thing you should be able to spot straight away by having two 60 degree angles, that this is going to be a equilateral triangle. So that's what it should look like, because obviously the remaining angle is therefore going to be 60 as well. So again, start off by making sure I've got enough room, so about 7 centimeters worth of height. So I'm going to mark 7.3, like I've done there. And then I go straight onto my protractor to measure one of my first 60 degree angles rather. So from 0 is on the inside numbers. I'm going to use the inside numbers to find 60, which is just there. And again, I'm going to use my straight edge of my protractor, draw it. I think that should be long enough. Then protractor on the opposite end, and again 0 on the line. So 0 is on the outside, so I'm going to use the outside numbers to find 60. Put a little dash, and then finish it off by a line through those points. Now that projection line is not as big in terms of that, so that's 60 centimeters, 60 degrees rather, and that's going to be 60 degrees. And again, I can always check to make sure this is correct, and this, if done correctly, should be 7.3. Yep, 7.3 and 7.3. Perfect. And there we go. Now when it comes to drawing the SSS triangles, again what you want to do is make sure that you're drawing the longest side first as your baseline. So for question 7 we've got 5 centimeters, 4 centimeters, 3 centimeters. So what I'm going to do is I'm going to go for the 5 centimeter line first. So when it comes to drawing a SSS triangle, again, the first step you want to do is pick the longest side to draw as your baseline. So for this question 7, we're going to go for the 5 centimeter line as our baseline. So again, to make sure you've got enough space, I would say recommend going for the height of the longest line, which is 5 centimeters. So make sure you've got 5 centimeters worth of space. In an exam, you really won't have any problem with this because obviously you just start at the bottom. So for this, I'm going to draw my 5 centimeter line, and notice I've picked a pencil this time in terms of neatness, and you want to try and get as close as possible to the 5 centimeters. So I'm just going to write 5 centimeters. And the next thing you then need to do is get your compass and your pencil. Now for this, setting up your compass in your pencil, you need to close the compass, make sure it's not loose, and if it is, you just need to get it tightened. So then what you want to do is get the tip of the pencil as close as possible to the tip of the compass, and then just make sure it's secure. And then the next thing you've then got to do is, with your ruler, measure one of the sides, so the distance between the compass and the pencil is the remaining side. So I'm going to go for the 4cm line first. So again, this can be a little bit fiddly and might take a bit of time. And again, you want to try and be as accurate as possible. You can see there that's 4cm. So what I'm going to do is going to put the pin on one end of the line. Now if you're not comfortable in drawing arcs, then just make sure you just give the standing leg of the compass a big tap. If it moves, then you're not putting enough pressure on that standing leg. And then what you then need to do is then just draw an arc in between the line. Now, it doesn't really matter how long your arc is, but it does need to resemble something that looks like that. Now the next thing you then need to do is set the compass at the remaining side, which in this case is 3cm, and we get 3cm there. Then put the pin on the opposite end, and again applying pressure on the standing leg, you just need to make sure that the arcs do intersect. Now this one you don't need to go crazy, just where you've got an X, as you can see there. Now at this point here, this is where that's the point that I need to connect to the opposite ends of the baseline. So what I'm going to do is I'm just going to connect that line up, and like same for the other side, like so. And then this side here is 3cm. That should be 4cm. So you can always check with your ruler by measuring 3cm perfect and 4cm perfect. And there you go. And again, a reminder, do not rub out the arcs. I know it's very tempting, but make sure you don't rub out those arcs because they are going to be essential. Now if you wanted to go over the triangle in pen, that's absolutely fine. I wouldn't recommend it, I think it's unnecessary, but again, as long as I can see a triangle and the lengths match up, then that is absolutely perfect. So doing the same with question 8, and again I'm going to use the longest side as my baseline. So again I'm just going to draw a line of 7.8cm. So again, trying to be as accurate as you can, like so. Again, I'm just going to label that 7.8cm and just give that a tick. So the next thing for me to do is set my compass to 6.5. So again, I'm just going to set my compass the best I can. So 6.5, just a little bit in. Perfect. And then again, set the pin on one end and then carefully draw your arc. And then repeat the process, but for the other side. So I'm going to do 3.4cm. And again, that should be spot on. And then moving the compass, the ruler out of the way. And again, what you want is the two arcs to cross, and that's what you're wanting. And then at this intersection point, all you then need to do is join that up to the respective ends of the line. And we have our triangle. And there we go. So we can label that 3.4cm and this 6.5cm. And again, you can always check by measuring with your ruler. Now with question 6, we can notice, well, the first thing I should notice is that all the sides are the same. So this is going to be an equilateral triangle. So from that, that's what I should bet. So in terms of height, again, 6cm. So I'm going to draw that here. Again, trying to be as accurate as possible. The good thing with this particular question is the fact that I only need to set my compass at once. Now again, I don't really need to use a ruler. Now if a question asked you to draw an isosceles triangle and that was already drawn, then all I need to do is just match that up, because I've already measured it as being 6cm, but this would be more of a lazy way of doing it again, like so. And again, you just draw the arc from one end and set the pin on the other end. Should meet the other end, which it does nicely. And you can see there that I've got my cross, which is at this point here. And the only thing I've then got to do is join points up. Now sometimes I've seen in old Key Stage 3 papers where they already drawn the lines for you, and rather than using a ruler, you had to match it up with there. But again, there would be my equilateral triangle. Now question 10 is another very popular question that comes up, and it says explain why you cannot draw a triangle with sides 8cm, 4cm and 3cm. Now as I mentioned earlier in the video, that you need to have two, and if you pick any two sides, the answer has to be bigger than the remaining side. So for example, if I picked 8 plus 4, which is 12, and 12 is bigger than 3. If I picked 3 and 8, 3 plus 8 is 11, and that's bigger than 4. However, if I picked 4 plus 3, that's 7, and that's less than 8. So it's going to be impossible. Now, to draw this visually, again, I'm going to draw my longest side, which is 8 centimeters. I'm going to draw an 8 centimeter line, like so. And then if I look at 4 centimeters, so with my ruler and my compass, I'm going to set this to 4 centimeters, which is there. And I'm going to draw my 4 centimeter arc, like so. And I'm going to do the same for 3 centimeters, which is just about there. And you can see there that the two arcs don't meet. So this here is my 3 centimeter arc, and this here is my 4 centimeter arc, and the arcs don't cross. And so that will be visual proof as to why you cannot draw this particular triangle. Now I will put a copy of the notes and some practice questions in the description below for you to practice constructing the 3 types of triangles you can get asked to construct.